start our session today with the session of Umul Kitab Al-Fatihah. Okay, so this is your last session with me. After this, you will be with Dr. Raha. So whatever I will discuss today is important because today I will talk about DNS. Okay. In the WhatsApp group, I said that I will give the video later on, but I think I will not do that. What I will do is that today I will cover everything. I will show you the video today. Okay. So this is the last day for you with me, and then there are no video later on. The video will be presented today. Okay, so that's one thing. DNS, there are no question on that. There are no quiz for DNS, but the DNS will occur in your final quiz. That's the second thing. So in your final quiz, all chapter will be included. The one that you have done, I mean the one according to your schedule, whatever you learn, the separating mixture, the TLC, the what we call the melting point, crystallization, and DNS, at least for my part, they will be they will be in your final. And after this, you will be with Dr. Raha. Dr. Raha will cover with the biochemistry, some biochemistry about DNA, and also about the microbe. So all that also will be covered in your final quiz. Okay, both my part and Dr. Raha part will be combined, and you will find the question in your final quiz. So that's one thing. Okay. So because today I will discuss about DNS and also show the video. So today's class will be around 1 hour like that. Around 1 hour like that. So let's start straight away with DNS. Okay, so if you look at your what we call lab manual, all of you have your lab manual. Let me open this like this. All of you have your lab manual. If you find DNS, let's say I control F and find the DNS, and then you go there, and then it's okay. So you see, previously we planned to have live stream, but there are no live stream because of technical problem. And there are no quiz also, but you have a final quiz, include everything. So let's go to here and here. Okay, the DNS experiment is basically experiment 2B. B stand for biochemistry. So DNS is here. Dinitrosalicylic. Okay, so this is basically a chemical. This chemical is used to sort of like giving indication for glucose or sucrose. You know, glucose is like a sugar, like sucrose is a sugar, the table sugar. Glucose is just simple sugar. Both of these, glucose and sucrose, if you put it in the water, they will be colorless. They will be colorless. They will be colorless like this. Nothing. So you don't know how much sugar you put. So the idea of DNS is a chemical. When you put that, it will react with glucose and corresponding to its amount. So somehow you get the color. Okay. So if let's say I have 2 bottles, one bottle you have twice the amount of glucose, and bottle B here, let's say bottle B here, there are only 1 amount of glucose. Then by adding the DNS, you can sort of like see those bottle A will have that twice the amount of the glucose, will give more intense color. So the idea of DNS is just to sort of like give some colorimetric method lah, so you can correlate with the amount. Okay, so that's for glucose. So DNS react with the glucose, but DNS do not react with the sucrose. Okay, so somehow you can use DNS method to what we call to differentiate whether this is glucose solution or this is sucrose solution. Okay, because after all, if you put glucose and sucrose in a 2 bottle, both are colorless, right? So DNS, because it can differentiate glucose and sucrose, then you can use DNS to make the distinction between them. The reason behind that I will discuss later. I just give you the idea first. So this is experiment 2B. So you can see here all this thing, all this intro you need to read and so on. And if you be in the lab, you will be given test tube, pipette, spectrophotometer. Okay, for spectrophotometer, what is this thing? This spectrophotometer, you actually have another, what we call another another lab for spectrophotometer. For example, here is 1B. Experiment 1, experiment 2B. Experiment 1B is about spectrophotometer. So, in fact, in order to understand DNS, in order to perform this DNS, you need to understand how to use spectrophotometer. Spectrophotometer is this. This one, in this, what we call experiment 1B. Okay, the use of spectrophotometer. What is spectrophotometer? The name imply that they have this spectro, meaning that is color. So it's somehow they sort of like can differentiate different shade or different intensity of color. For example, if the color is pale, the number that is given is lower lah, maybe 0.0, 0.01. If the color is little bit intense, maybe the number is 0.02, like that. So somehow you have the machine that can give sort of like numbers to the colors lah. So you can use this because every person eyes, when they see something, for example, there are two beaker, one is paler, one is darker than this. Maybe for that eyes, that person eyes, that this thing, what they see might not be the same what you see. So that's why this spectrophotometer give sort of like some quantitative ni lah, value to the color lah. So that is spectrophotometer. We will see later on how to use spectrophotometer. So that's basically it. You need to know spectrophotometer. You also need to understand what is the purpose of DNS. What is the purpose of DNS? What is the purpose of DNS? And then you have these two things, spectrophotometer, DNS. Then you can do it for this lah, to detect glucose and also to find whether it's glucose or sucrose, and also to find what is the concentration of glucose. Okay, so that is generic idea lah, generic idea about this. Okay, let's go here. Let's go a little bit about the theory. Okay, so now you know three things. You have a spectrophotometer, and then you also know DNS. You also know this experiment deal also with the glucose. You also know the experiment also deal with the sucrose. I want to talk first about glucose and sucrose. Okay, when you see glucose, all of you have taken the organic chemistry, okay, or maybe you are taking it now. So glucose can be sort of like exist in two form, either open chain like this. You learn in organic chemistry, you have this CH2OH, and then you have something like this. This open chain glucose. You have OH, you have OH, and then here you have OH here, and then you have this another one here, OH, and then H, and then here you have what we call the aldehyde group, O and H. Okay, so this is H, this is H, this is H. So this is glucose. This is glucose, and glucose also can convert itself to the cyclic form. Okay, the cyclic form of glucose is like this. You have this is organic chemistry. This is basic organic chemistry, you should know lah. So this OH under this up, and then you have something like this OH. So this OH, and then this is basically OH lah. Okay, so both of these is a glucose. Both of these are glucose. Okay, so this is what we call open chain. We call it open chain. This is closed chain. Okay, when you put glucose in water, when you put glucose in water, let's say you have the beaker of water here, and then you put this glucose, you put in the glucose, most of the glucose what we call exists as a open chain. Most of glucose exists as open chain, this thing. Not open chain, the closed chain, the cyclic. almost 99% of it is cyclic. Almost more than 99% lah is cyclic. Only a few is open chain. Okay, the way how DNS work is like this. DNS, let me talk about DNS for a while. So DNS is this. Let me, how to make bottom. Okay, so this thing. Okay, so DNS stand for 3,5 dinitrosalicylic acid lah. So it's basically have something like this. So this, they have something like a benzene like this, and then you have NO2, and then you have NO2, and then you have what we call the acid group here on the top, COOH, and then you have also the OH here. So this is basically 3,5 dinitrosalicylic acid. Okay, it's just a chemical, it's just a powder. It's just a powder, and this, if you put in water, it give the color of yellow color. Yellow color. So this thing is DNS. I put here DNS. So this is DNS. Okay, so DNS is what we call it can be reduced into another thing if they found the free aldehyde or free ketone. Okay, so DNS, okay, the reason why we use DNS, if let's say it meet with the free carbonyl group. Carbonyl group is basically when you have this lah, CO, and then you have RR. Okay, so if you have something CO, and then you have this is R, and then one is H, this is what we call aldehyde. Aldehyde. This is what we call ketone. Ketone. This is ketone. Both of these are the carbonyl group. Okay, you have ketone and aldehyde. When you see this, when what we call, when the DNS saw this thing, react with this thing, it will be reduced. The DNS will be reduced. Reduce. Meaning that it will take something here from the aldehyde or ketone, and then the structure will be changed lah. Okay, so the structure will change into this. You have something like this also, and then you have something like this, COOH, and then you have OH, and then but here you have, instead of NO2, you have NH2. It's something changed. It become reduced. It become reduced, and this is NO2. Okay, so this. So basically, it will change from 3,5 dinitrosalicylic acid toward what we call 3-amino, and then 5-nitro salicylic acid, salicylic acid. Okay, when they change this, the color also change. Okay, the color now you get something like orange red, or reddish like that lah. Like a brick. Like a brick is like dark red, not dark red, dark orange red. Orange red lah. It's like a brick, batu-bata. The color from yellow it become like that. So you have this color change. So you know, when you put DNS into some solution, and suddenly the color change, you know that inside the solution there are ketone or aldehyde, the free ketone or free aldehyde. If you look at the glucose structure here, let me put here, let me take here, make it easy like here. Okay, if you see the glucose structure here, you can see that they are like this. You see this thing. So this is aldehyde group. Aldehyde group. Okay, so because it's open, so we call it free aldehyde group. Okay, so now you have DNS, you have a solution of glucose, then you will get what we call the color will change lah. So from this colorless, you put DNS, so you get yellow first, and then over time it become what we call, when the reaction happen, it become reddish red. So you know this solution is a glucose solution. Okay, so that's at least lah, if you know you only work with glucose. Okay, let's see about, so we done with the DNS and also the glucose. So now let's see about sucrose. Okay, let's see sucrose. So let's see sucrose. So let's say I grow sucrose. Okay, sucrose. Sucrose also simple sugar. So you learn in organic chemistry, you have simple sugar like this, and then you have this OH, and then you have this OH, and so on lah. OH, let me draw like this, and then you have this here, you have this OH, but here you have this because sucrose is 5-membered ring. I mean, you have 5 carbon, so you have C here, O, and then you have on the top of here you have C, and then you have what we call the OH and H lah. OH and also H lah. Okay. Kenapa macam ni? 1, 2, 3, 4, C, sucrose. Let me check first. Fructose open chain. Let me check first. Fructose open chain. Is it correct or not? Fructose open chain. Fructose open chain. Is it like that or not? Okay, let's go like this, and then I go to image. So you see CH2, CH2OH. Fructose is CH2OH. That's why when you have what we call the carbon, it will need 2 hydrogen, so meaning that you have something like this lah, something like this. H and H like this. It's much better like this lah. Okay, so you get something like this lah. Okay, so that is sucrose. So let me bring this down. Okay, let me bring this down a little bit. Okay. Okay, so that is sucrose. And if you look at where is the another one down there? So that is the other one is CH2OH lah. CH2OH, and then this H. Okay, so if you see the what we call the this so let me draw. This is 1, 2, 3, 4, 5, 6 lah. 5, 6. They have 6 5 of 6. But then when you do cyclic, okay, so you have 6 carbon. If you see this glucose also, you have 6. 1, 2, 3, 4, 5, 6. You have 6 carbon. But then when this sucrose go into this closed chain means that it becomes cyclic. It become this 5-membered ring. It become like this. O, like this, and then like this, and then this is OH, and then this is OH. Let me draw carefully. Become like this, OH, and then you have this top and bottom lah. OH and OH lah. Okay, let me make it like this. Okay, so you get something like this. So like this, and then you have something like this, OH, and then you have something like this, OH, and then you have something like this, OH, and then you have something like this, OH. Okay, so basically this is sucrose in the cyclic form. Okay, both of them are sucrose. Okay, similar with the glucose, if you put in the water, some of them will be in cyclic, some of them will be open chain lah. So this is what we call open chain. This is what we say closed chain lah, close or cyclic lah, closed cyclic. Okay, cyclic form. Okay, so sucrose, whenever you put in the water, it will be in equilibrium. There will be something like open chain, there will be something like a close. It's not like 100% must be a cyclic formation inside the color. So because when you put in water, all of this will occur in equilibrium. That means this thing, it will occur in equilibrium. Okay, if you look at the sucrose, you can see also sucrose also have this part. You have this and this. So this is ketone group. This is ketone group. For aldehyde, you see for glucose, you see this is what we call aldehyde group. On top of that, you see is aldehyde group, free aldehyde group. But for the sucrose, you have this free ketone group. Free ketone group. So because you have this free ketone group, it's same reaction happen. DNS, when you put DNS together with that, and then DNS will react with the sucrose, then DNS color will change into the orange red. Okay, so for time being, no, sucrose is not this. This is fructose. This is fructose. This is not sucrose. This is fructose. Sorry, this is fructose. Fructose, okay. So you see the fructose, fructose like this, fructose like this. Fructose like this. So you can see fructose also has free ketone. So both glucose and fructose is a simple sugar. It's a simple sugar. So glucose and fructose is what we call simple sugar. Simple sugar. Because if you look at the molecule also, it's just one thing, right? One thing only. One thing for fructose, one thing for the glucose. So now let's look about sucrose. We know that DNS give a positive effect to the glucose and also the fructose. Because of what? Because of this free ketone or free aldehyde group. So we can say that this fructose, this glucose, and also fructose is a reducing agent. Is a reducing agent. Because why? Because when you add DNS will be reduced to the 3,5-dinitrosalicylic acid will be reduced into 3-amino-5-nitrosalicylic acid. Okay. So glucose and sucrose is a reducing agent, meaning that it will become oxidized, whereas the DNS will be reduced. It's like redox reaction. They are something that is oxidized, they are something that is reduced. The reducing agent will be oxidized. Okay, reducing agent, it will be oxidized because it's reduced something. So something else that is reduced become reduced, but the reducing agent itself will be oxidized. So that is redox, that is chemistry. You should be able to sort of like be familiar with that, because you are taking this biotech, the biochemical engineering. So chemistry should be like this. If you feel this is hard, then it's problem lah, because you already taking the organic chemistry. I think you currently taking the organic chemistry. Okay, so now, so you have fructose and the glucose, both are simple sugar and both of them are what we call react with the DNS. What about the sucrose? Okay, let's talk about sucrose a little bit. Sucrose is combination of glucose and also the fructose. That's why I talked about the fructose before. Sucrose is a combination of glucose and the glucose. So this is sucrose is disaccharide, meaning that if you want to draw the structure of glucose, you will draw like this. You have something like this, the glucose part. So you have the glucose part like that, and then you have OH, and then OH, and then you have this OH, and then also you have this glycosidic bond. You have what we call, let's say I draw in the different color lah. So you have here, you have something like this, you have this fructose part. You have fructose part here. So you have OH, and then you have OH, and also you have this OH, and then also you have this OH lah. OH like that. Okay. So you see they are fructose and also glucose combined together. When they combine together, you see there are no more free aldehyde group or free ketone group. Okay. So there are no more free carbonyl lah, free carbonyl, because carbonyl mean aldehyde or ketone. Carbonyl is a big class. Under carbonyl you have aldehyde, ketone, acid, and so on. There are no more free carbonyl group. In this case, no more aldehyde group for glucose, no more aldehyde group for the fructose. So this here is a fructose, fructose, and here is a glucose. Okay. So because sucrose is disaccharide, they are no like open chain like that. Because they are disaccharide, in order to say something is as a sucrose, it must be disaccharide. Okay. When you have disaccharide, there are no like open chain because it's already combined. So there are no open chain. So this is a disaccharide. So sucrose, the sucrose is basically your table sugar lah. Your table sugar, you go to your mom kitchen or your home kitchen, it's basically the table sugar. Okay. The thing that makes sugar what we call sweet is a fructose. Glucose is sweet, but fructose is more sweeter than the glucose. When you take a sugar, when you consume it, what make it feel what make it what we call taste sweet is because of fructose. Glucose is okay, but fructose is more sweeter than the glucose. So table sugar is combination of this glucose and fructose. Okay, if you see like this, sucrose doesn't have free carbonic group, meaning that if you have sugar water, sucrose water, and then you put DNS, nothing happened. Okay, nothing happened. The DNS will stay in yellow in color. Okay, so that's one thing. So now you know that DNS can differentiate between the sucrose and the glucose or the fructose. So sucrose is disaccharide, glucose and fructose is simple sugar. Okay, all simple sugar, okay, all monosaccharide, or we call it monosaccharide is can react with the DNS, give a positive reaction to DNS, meaning that it can reduce DNS. Okay, but once it goes to disaccharide, polysaccharide, then it cannot react with the DNS. Okay, so that's the idea behind what we call this thing. But before we go further, let me see how the reaction happen. So you have, let's say you have glucose, or you have a sucrose, not sucrose, fructose. Let's say you have, let's say glucose lah, glucose. How you do it is basically you add with the DNS. Let me put how the reaction happen is that you add with DNS, okay, DNS, and then you need to heat it. You need to heat in order to kick the reaction. If you add just like that, then nothing happen. You need to kick for the reaction to happen. So you need to add heat, and also you need to put in the alkali condition. So that's why when people prepare DNS, here, they will prepare in alkali solution. There will be alkali around together lah with the DNS solution. Okay, so now when you do this thing, glucose, and then you add the DNS, you supply with the heat, and then around like 5 minutes, heat around like 90 degrees Celsius lah. Around 5 minutes like that, now you can see the DNS will be converted, as I said before, it will be converted into this 3-amino 5-nitro acid lah. This one lah, it become something like this lah. It become this COOH, and then this is become OH, and then you have NH2, and then you have this NO2. Okay, so this, you know, the color is reddish, reddish orange like that. And of course the glucose, the one that what we call the one that is open, so you know it's react with the free aldehyde only. So this thing, the glucose, you have something like OH, and then this OH here, and then OH here, and then you have this what we call, you have CO and H here, and let me draw H. Okay, so this, when it react, what will happen, it become this become reduced lah. This become reduced. I think they become COOH here. Okay, instead of this, it become like a COOH. This thing, they become O here. Okay, they instead of H only, now you have OH. Okay, let me see, is it correct or not? Okay, let's see this thing, DNS. I think they, okay, oxidation doesn't put here lah, but I think they will reduce to this lah. Okay, so if you read here, the method test for presence of free carbonate group, so called reducing sugar. So reducing sugar is basically the what we call our glucose lah. This involve oxidation of aldehyde. Okay, so the sugar become oxidized. Okay, aldehyde functional group present, for example, in glucose, and ketone functional group in fructose lah, the one that I tell you, ketone and aldehyde. simultaneously 3,5-dinitrosalicylic acid reduced to 3 amino blah 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 here and so on. So I will talk to you lah. Okay, and so on, you can read lah, whatever. Okay, so that's basically what happened lah. So let me put here CH2OH lah. Okay, so that's basically what happened. But for sucrose, it will give you nothing happen lah. So I want to stress here lah how to kick the reaction. Okay, in term of glucose, sucrose here, if I take here, if I copy Ctrl C and then I put here, so that is the use of Ctrl C. It's not for you to copy your friend report or whatever, just to help you to make things faster. Okay, so you have this sucrose, you have this sucrose. If let's say you can cut this with the acid. Normally they cut with the acid, then you can get this glucose and fructose separated. Now when it's separated, then you have this what we call the open chain and the closed chain. So now when you, let's say you put sucrose, let's say you have sucrose, let's say I have sucrose here, and then I add with the DNS. Let's say I add with the DNS here. Let me put the color yellow there. Initially there will be nothing happen, no change in color lah, But then if let's say if I copy this thing, copy lah. If I put sucrose and then I add acid first, I just add acid and then I heat this thing so that the acid will react with the sucrose. What happen is acid will break the bond between sucrose and glucose and fructose, and then after that I add DNS, and then I do the reaction, meaning that I kick the reaction by heating again. Then now you have what we call the positive result, change in color. Okay, so same sucrose, but then for the second part, let's say this is A and this is B. For B, you break the sucrose, and when you break, then it become glucose and fructose lah. Okay, you might ask, okay, if I said before, for the glucose, the open chain and the closed chain exist in equilibrium. So, and I said before, this cyclic form dominates a lot. So by putting the DNS, it just react with this only. So what about the rest? What about this thing? So the answer is that once you react with this, once DNS react with this free aldehyde group, the equilibrium of open chain and the closed chain will be disturbed. So then when this equilibrium disturbed, some of the closed chain will open again, so they will maintain the equilibrium. So then another DNS will react with this with this open chain, and then it will disturb the equilibrium again. So to the point that over time all this thing become the open chain lah, in order to maintain the equilibrium of between open chain and the closed chain in the solution. So that's why even though initially there are only few of open chain glucose that have free aldehyde group, but because when DNS react with this thing, the equilibrium of between the cyclic and open chain will be disturbed. This cause this thing, some of the closed chain will be converted into the open chain lah, in order to maintain the equilibrium. So basically that is the theory of DNS. Any question now? Any question? Before I show you how actually people do it. Aina, are you here? Aina Nadira, are you here?
Yes, sir.
Any question?
So far, not yet.
Okay. So whatever you see in you see what we call our lab manual, right? Lab manual said that, okay, you conduct the experiment, this thing, glucose and sucrose detection by DNS, blah 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 blah. But you need to, sometimes people wonder from where people know this. Okay, all of this, all whatever you read in your book, in your lab manual and so on, there will be someone that is pioneering that, someone that is starting that thing, and then that when they start and become valid and famous, and then people use it for that. For this DNS, the what we call the earliest, I mean the famous paper is this. Let me open this thing. Okay, the famous paper is this. Is 1959. Okay, so this in 1959, Gil Lawrence Miller, they write a paper. This is 1959. 1959. Okay, so the old one, the old paper. But this is the start of why people use this DNS. The use of dinitrosalicylic reagent for determination of reducing sugar. Okay, so this is the paper. So you see the paper is like this. So all this thing lah. So that's the paper lah. So they tell you what? In this paper, they tell you what? Rochelle salt. Okay, so here they have the word Rochelle salt. Okay, what is Rochelle salt? Rochelle salt is basically, let me talk about Rochelle salt a little bit, because Rochelle salt have been used also when you perform DNS. Okay, Rochelle, let me put in read lah, because it's Rochelle salt. Okay, the other word for the other name for Rochelle salt is potassium satu je, potassium tartrate tetrahydrite lah, tetrahydrite. I mean, this is just a chemical lah, but the fancy name is Rochelle salt. People use this in order for what? When you try to do this, okay, when you try to have a glucose and then you add with the DNS, okay, let me put in red color, and then you kick the reaction by heating it, okay, and then you get the reaction. Let's say I put this thing as a reaction. Let's say I put like this lah, orange color lah. I put orange color. Okay, when the orange color is developed, if you keep heating it, the orange become darker and darker. Okay, so you do this 90 Celsius only for 5 minutes only lah, around 5 minutes only, and then you take it out, and then you read in the spectrophotometer. But if you take out from this beaker, hot beaker, that thing, the color will become darker and darker and darker over time. So you need to stop that color development. So Rochelle salt here, the purpose is to stop, to halt, HALT, halt the color development after the reaction happened. Okay, because why? Because maybe you do a many batch, and then if you just left, for example, you do 10 batch, you take the first batch and then you put after reaction you put in somewhere, and then you work with the second batch, third batch, and then you combine together everything and put in the spectrophotometer. You will see your result will be not so good lah, will be not valid, because the first batch, the one that you take early on, might the color might be become darker and darker, so it will not correspond to the actual actual glucose that has been reacted before lah. So you need to stop. After you react, you need to stop the what we call the color development. So you use Rochelle salt. So that is basically Rochelle salt is just also a chemical, like a powder lah, powder. So you have this thing. So you see Rochelle salt, no, blah 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 blah, normally present in dinitrosalicylic acid, blah 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 blah, and then you have also sulfide. For example, this is to make DNS. Okay, you have sulfide, whatever here. Okay, see method. So if you look in the method, you can see the recipe. It's like when you want to cook something, they need a recipe, right? So you see the former, okay, the former use this, meaning that previously people also what we call before this paper, there are some people also work with the DNS and reducing sugar, but they use this concentration 0.63 and so on. Come this guy, they modified the reagent, so you have this thing now. So let me put in the different color. Let me put in this green color. So you see, this is how research work. Okay, the reason why the yellow one here, the former one, doesn't really work because this author found that it's not the test is not sort of like robust, I mean that it's changed because of this, because of that, and so on. So the author tried to change the concentration a little bit, and at the end he get this lah. Whenever you see people work with DNS, normally they use this concentration lah, more or less they use this modified DNS reagent concentration. So basically you have this, you see, you have DNS, you have phenol, you have sodium sulfite, you have sodium hydroxide. Sodium hydroxide, you see before I said that in order for this reaction to happen, you need to put in the alkali. So sodium hydroxide provide the alkali environment. Okay, DNS. Okay, DNS is needed lah in order to what? In order to react. Okay, phenol. What is phenol? What is the use of phenol? The use of phenol here is to what we call to increase the color, to make the orange color. For example, remember from yellow become the reddish. So the task for phenol is to make the color more intense. Meaning that if let's say you test a very low concentration of glucose, okay, if let's say the color change is very minimal, then depending on your spectrophotometer, maybe your spectrophotometer is so old, it's not so sensitive enough, it cannot read that. It cannot make a differentiate between that color. So the purpose of phenol here is to increase the intensity of the color that is developed later on. So that is phenol. Sodium sulfite. Okay, the purpose of sodium sulfite is that inside any water, there are oxygen. So this oxygen can also reduce the glucose free aldehyde. So sodium sulfite, somehow they sort of like protect this from happening lah. So let's see, is it correct? Let me see, sodium sulfite. Do you see phenol concentration? Let me see. Mana? Whatever lah. But if you look in your lab manual, but they tell somewhere here lah about about the purpose of sulfite. But if you look at your lab manual, it said that dissolved oxygen can because dissolved oxygen can interfere with glucose oxidation. Okay, sulfite, which itself is not necessary for the color reaction, is added in reagent to absorb the dissolved oxygen. Because without sulfite, the oxygen can also react with the free aldehyde on the glucose. Okay, so you put sort of like sulfite in order to grab that dissolved oxygen inside the solution. Okay, so basically that is the thing. So if you look here, they are what you have learned today is that you have spectrophotometer. You also learn DNS here. You also have NaOH. You also have sulfite. You also have phenol. You also have what? You have also have the Rochelle salt. Rochelle salt. Okay, so this is the thing that normally you found when you deal with the DNS. Okay. So now, how this is conducted in the lab? If you are in the lab, then you are theory. It's like you go to organic chemistry class. You learn the theory, yeah, fine. But then, if you can have this experience going to the lab, doing the thing, then it's much more much more. The feeling, the experience that is different. No matter how much you read, it cannot be the experience. That's why you need to respect the old people. The old people, maybe your knowledge is better than them, but they have experience, and you cannot beat the experience. Okay, enough talking. Let's talk here. So how to prepare this thing? What is this experiment all about? What is this experiment all about? This glucose and sucrose detection, blah blah blah, and so on. What is this experiment all about? The experiment is this. If you are in the lab, what we do is this. We give you what we do in the lab. What we do, we give you a beaker, whatever beaker, and then we put a glucose inside that. Glucose. We don't tell you whether it's glucose or not. We give you 2 tube lah. Okay, they are also sucrose. Okay, we give you 2 tube, have a glucose and a sucrose, and then you don't know which one is glucose. Let's say we put X, we put Y. Okay, sama sangat lah. Let me put A and B lah. Let me put A and B. So we label A and B. So you don't know which one is sucrose, which one glucose. So you know the DNS can differentiate. So that's easy part. Okay, that's easy part. You just put DNS, you react, and then you know that glucose will turn into this thing. The color will turn into the reddish. That's easy part. The other part is that you also need to tell us how much. First, they ask you which one is glucose, which one is sucrose. Okay. The second part, they ask you how much glucose inside. After you know which one is glucose, then they tell you how much. Then what is the concentration? I mean, in terms of concentration lah. Concentration. Okay. So to solve for question number 1 is easy. Okay. But number 2, you need to do something else. Okay. Because you are given, imagine that I give you this thing. Inside this there are glucose. But you know, even though you know this is glucose, then I ask you how much glucose I put. Because glucose is powder, right? You put inside that. But now you don't know how much I put inside. So the task now is how much glucose that you think I put inside this bottle. So that's the second question lah. So how to know this is basically what we do is that we need to create a standard. Okay, we need to create a standard. We need to do an assay. An assay meaning that you need to prepare a series concentration of known concentration. For example, let's say you know this is what we call 0.2, 0.4, 0.6, 0.8 and 1.0. Let's say gram per liter glucose. And then let's say this is you put absorbent lah. Absorbent meaning that because at the end of the day when you react with DNS, the color develop. Okay, the intense the color, you correlate with the more glucose. So how to give the number for that? So the idea is that you shine a light to anything. For example, you have something like this. Let's say you have this, and then you have the glucose inside, and then you shine the light. Let's say you shine the light. Okay, let's say I put light, and then if this thing is darker, let's say this is a solution is darker, then you know that some light will be absorbed. Okay, and the light that is coming out will be a little bit pudar lah, a little bit what we call pale. The intensity is not so high as this the incoming light. Okay, so imagine now the spectrophotometer is basically doing that. So spectrophotometer is basically, this is like say spectrophotometer. Let's say we put in this black box, the green box as a spectrophotometer. So the spectrophotometer somehow will sort of like see the difference between the incoming light and then the outro light lah. So they see the difference and then they give you, because this is like the control lah. So they will give you the amount lah, the what we call. They give some sort of like value lah, the absorbent value. So you get the value. The higher the value, meaning that the darker is it. Okay, so let's say the absorbent here is 0. Let's say we put arbitrary lah. We put 0.3, 0.4, 0.5, 0.6, 0.7 and so on. So now you know, if let's say you create a different concentration of glucose, you see the more glucose, the more it will react with the DNS. So by right, the number will become higher and higher. So you will get the graph like this. 0.2 maybe is here. The number is around 0.3. If you test 0.5 gram per liter glucose, maybe here. Maybe here. 0.8, maybe here. 1 higher, even higher. So you can create a graph. So this is what we call standard curve. Standard curve. Standard curve means that you create a series of concentration, 0.2, 0.5, 0.6 and so on. You create a series of known concentration. Okay, so you know this thing, and then you put in the spectro, you get this thing, so you get the standard curve. So now, if let's say the A is a glucose, you don't know. Let's say this is, you don't know how much glucose. You put this glucose inside the spectrophotometer, and the spectrophotometer will give you some numbers. Let's say spectrophotometer give you around here. number 0, let's say spectrophotometer give you 0.47. So somehow here. So you know from the standard curve, you can interpolate blah 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 like this, and then you know roughly the concentration inside the unknown A is around 0.6 something, 0.62 or whatever lah. So that's how you sort of like find the unknown concentration. You need to create the create the standard curve of the known concentration first. So in order to answer for number 2, question number 2 there, this question number 2 here, first you need to create this thing first. You need to create the glucose with the known concentration. Okay? And then you, after you plot the standard curve, only then you can sort of like what we call the interpolate the the absorbance of the unknown. Okay, so enough for the theory. So now we go to the what we call the how they do it. So let's say I want to create this glucose concentration, the known glucose concentration. So let's see how we do it. I put here. Let me wait open widths. Let's see. Okay, let me close here. I need to do this thing first. Okay, let me close this first. Let me do this first. Open widths. Masih media player. Ini besar juga lah. I use this lah. Salah ni. Sebut ni. Okay. Okay, so I close the what we call the sound there, so it will not interfere. Okay, so if you look here, in front of me there, they are like glucose and the sucrose. Glucose and sucrose. Glucose and sucrose there. So basically what I did just now is basically I want to create the known concentration of glucose and sucrose. So I need to what we call to somehow to calculate. Okay, you need to calculate. If let's say you have 1 liter, you want to create 1 gram per liter, you need to put 1 gram lah in 1 liter of water. So you need to calculate lah. You need to calculate everything. And then here, if you look here, I'm using this volumetric flask. So that is volumetric flask. Okay, if you look there, there are 500 ml. Okay, 500 ml. So you can see there also the mark there. The mark there. So meaning that if you put a water until this mark, then it will sort of give you the idea of 500 lah. It will give the amount is, the volume is 500 ml. So if let's say I want to do 1 gram per liter of glucose, so in order to put here, I will put half. I put half because I don't have 1 liter flask. I have half liter flask. So in order to make 1 gram per liter, I need to put half of glucose inside that. Okay, so you just sort of like calculate first carefully, because once you put it, then you cannot go back lah. So that's the first step is always plan first. Plan first. Okay, next. Once you calculate that thing, now we start to sort of like putting the thing inside this beaker lah. So basically there, you can see that I just pour the 0.5 gram of glucose into the beaker, and then I run the water to it so that the leftover of the glucose can go inside lah. And then I add the water, the distilled water, to reach the mark that I showed before lah. So after you get all this thing, after you sort of like you get what we call. Okay, so after it reach the mark, what you do is that normally you shake the flask lah, shake the flask in order to make it homogeneously dissolve. Okay, so you shake like that, and then after you shake, please make sure don't forget to label. Okay, because After this, I will do also sucrose. Sucrose, if you create the thing, is also colorless. So it's very important when you do thing in the lab, you must label. That is very important. Often, people forget to label thinking that they can remember. But there are many instances that you will forget. Not forget, I mean that you sort of like, you take the wrong one. And then when you take the wrong one and you think this is the right one, then all the result will be useless lah. So you must label. So that's how you make the glucose, the known concentration of glucose. Okay, so now I do the known concentration of sucrose, because now I want to do the sucrose. The same thing, but the idea here now is I'm creating the stock. The stock for the glucose 1 gram per liter, the stock for the sucrose 1 gram per liter. And in order to make the series of the concentration, I need to dilute it. In order to make like this, in order for me, let me stop this thing. In order for me to make something like this, I need to dilute it. And you know, when you want to dilute, you use this formula M1V1 equal to M2V2. This all of you have learned in the chemistry lah, the basic chemistry. So you just dilute it. You add water and so on. Let me see whether I have that thing or not. Okay. Okay, so this. I want to start to dilute. So now you see there are 4 flasks. This is glucose that we did. This is sucrose. This is potassium, the Rochelle salt. I will show you later on how to do this thing. And this is the DNS. The color is around yellow like that lah. So let's see this thing. What I did just now is basically I want to make a series of concentration of glucose. So again, the important thing is to what we call to really calculate M1V1 equal to M2V2, because you want to add water to dilute it. Okay, so you have a stock solution 1 gram per liter. The one that I did here is 1 gram per liter, and then I want to dilute it. So if you look over there, you can see I take the what we call the apa tu tube, Falcon tube. Okay, because I don't want to dilute the entire flask. It's rugi lah. It's wasteful. So I put in the small flask. So for small tube lah. On the small tube, I put the label. Okay, this one will be 0.8. This one will be 0.7. 0.6, 0.5, 0.6, whatever lah. And then I dilute there. So basically, you see there, I already calculate everything. And then, so the way how to dilute, before dilute, you must make sure, again I said, always label when you are in the lab, because now you are, I call it a lost generation that is no hands-on. So later on, if you are be able to be in the lab later on, make sure you remember all these things. Always label. Okay, always label, even though it takes time, label. Okay, now after you label, so how I dilute it? Okay, so how I dilute it? Okay, so the first thing, when I want to dilute it, I will put whatever glucose. For example, now I want to dilute the glucose. So I take the glucose and I put in the small beaker. I put in small beaker. Okay, the reason why I put in the small beaker, because I don't want to use this big flask straight to what we call to the tube. Okay, the one in the cap, blue cap is a tube. I call it tube, but I put in the small beaker first. Okay, the reason for that is that so that it will not splash and so on, and also I can use thing in the volumetric flask later on again and again. So I have a lot. I only need a little only in order to do the experiment. Okay, so if let's say this experiment is failed, then I can reuse again whatever the stock solution, the 1 gram per liter glucose solution again and again. So I not repeat the thing. So in order to dilute, I need to take what we call the micropipette. You learn micropipette in the first class. I mean, even though we give it a video. So the micropipette. So the idea for now, what I did is that I want to take some amount of glucose. For example, the one in the beaker just now. So you see, I take the pipette and then I open the thing. This thing, when you want to do this, you need to go very relaxed lah. So you take the pipette. When you handle the pipette, make it is straight lah. When you want to aspirate, make it vertical, and then you put inside the tube. Okay. So now that's amount, the one that I pipette, I already measure later on, right? And I already measure before. Okay. I already measured the one that you see I write on the paper. So once I do that, and I can add the water to this thing lah in order to dilute. Okay, but for time being, I put all the glucose first lah. I'll put all the glucose, but later on you will see I will add the water lah. Later on I will add the water lah. I will add the water, and then it will be diluted. So that's how you make the known concentration of what we call this thing lah. So that is a tube There's a tube, empty tube. Okay, so that's how I do things lah. Okay, so now you have this series of concentration of blah blah thing lah. Okay, so that's about glucose. Glucose. Even if you want to do for sucrose, also the same thing lah. If you want to make a series and anything, if you want to make a series of concentration, or if you want to make a standard curve, that's the way how you do it lah. You basically you dilute the thing or ni lah. Okay, and then let's see the big picture first. Okay, this is the thing that you need to use. Okay, for example, whatever in front of you now is basically the thing that normally you use for DNS. Okay, so this is beaker, and this is what we call the pipette. You know this pipette, and this is the cuvette. This cuvette, the one that you need to use. The cuvette is basically in this small square thing. So you put your, later on when you want to put into spectrophotometer, the machine is here. The machine is the back here. Okay, they only accept this cuvette. So meaning that you put your whatever color thing inside this, and then you put in the machine. Okay, so you see they are, so whenever you want to start any experiment, you need to be prepared well lah. So for example, here I have a sucrose. And also I have a glucose, the one that we want to work, right? This is DNS. Okay, DNS. All come with in the what we call in this what we call this thing. This powder lah, powder. So this phenol. Okay, phenol. This is sulfate. Okay, the reason why we use sulfate, remember this is hydroxide. Okay, potassium hydroxide. We don't use sodium hydroxide. The same thing. It's alkali. To make it alkali. This is potassium sodium tetrahydride. This is Rochelle salt. This is what? This hydrochloric acid in order to break the what we call the sucrose. This is what? I don't know what is this. Oh, not clear. Not clear. Okay. Okay. So this all the thing that you need to have lah in order to perform the DNS . Okay. Let's see how to make DNS . How to make DNS. I put here and then I put here to make it small. Let me make it small first. Let me put here. Let me make it small first. Okay, in front of you is basically the thing that the chemical that I already weighed. You see on this white thing. You see I already put in the I already weigh everything of it according to the recipe lah. So that's why we see the recipe. So you can see the color of DNS is around a yellow a little bit, and then you have phenol and so on. So the idea to make DNS, in fact, if you use this alone and then you add water, that's enough actually. But remember, you need the alkali condition in order for reaction to happen. So that's why you need to also this thing lah, the potassium hydroxide, the phenol also we add in order to what we call to increase the color. And the sulfide also and so on. So you can see the way how I put that. Okay, so you see the color become yellow. Whenever you put that, the color suddenly become yellow. And then we go straight and so on. So you just add the recipe lah. So you just add everything. And then that's it lah. You get after you add everything. Okay, after you done, you add everything, you see the color there. Okay, and now I want to make all this thing up to the mark here. Okay, remember here, in order to know the amount, you need to calculate lah. Need to calculate everything. So you get everything, and at the end you finish lah, and so on. What is that? Okay, so let's see now. So now this how I did how to break the kenapa dekat sini? Okay, so this how I add acid to the what we call to the sucrose. You have sucrose also, right? This is sucrose. So to break the acid, to break the sucrose is basically, so I take the sucrose there. Sucrose ke tu? Glucose. That's glucose. That's glucose. Okay, so I just put like that. So this is basically what? Basically I want to see, to differentiate which one is glucose, which one is sucrose lah. So basically that is glucose. The one that I take now is a glucose. So I put in one test tube. If you look there, I also already label the test tube. So you need to label. So that is sucrose. You see sucrose and glucose almost are colorless. So you put that and then you put the sucrose on the second one. Okay, so that's sucrose. And then now what I did now is I take the acid. I take the acid, the hydrochloric acid. Okay. And then I will add to the sucrose. There are one tube that I don't add. They are sucrose without anything. There are one tube, they are sucrose with the acid. Okay, with the acid in order to sort what we call, to see the difference. And then in order to break the, what we call the, okay, so you have this thing. In order to break the bond between fructose and sucrose in a sucrose, fructose and glucose in a sucrose, you need to put acid and also you need to heat up. Okay, you need to heat up. Okay, so basically you just heat the water on the stirring. So you put this sucrose with the acid. I heat it in order to what? Because the heat will speed up the reaction of breakdown of the sucrose lah. So that's why I heat the thing. Okay, only then after that I put the DNS. Okay, so this is the thing. Okay, so now so this how you add the DNS. So now you have here, you have in front of you, you have glucose, you have sucrose, and you have sucrose with plus the what we call plus the acid. And this just control lah. Control meaning that just water and so on lah. So the way how you add the DNS, just simply you take DNS just now inside the flask, you put in the beaker, easy for you to handle. You take the what we call the pipette and then you aspirate it. Because I'm using 3 ml of glucose and sucrose and so on, so I put another 3 ml lah. So just so that it balance lah. It depends on your recipe lah. So this I put 3 ml of DNS. So now you combine the DNS with the your glucose or sucrose lah. So now, okay, so now that's the thing. So up to now nothing will happen. You need to kick the reaction. You kick the reaction with the heat. Okay. So now this is what happened when you put in the what we call. So now this how to kick the reaction. You take all this thing, the same thing pula. You take all this thing and then you put on the hot water bath lah. Okay, you can just put on the hot plate and then you put water and then you ni lah. So over time let me fasten this thing. Okay, over time you see there are some color change. Some color change. You see the one that I put just now is a glucose and also the sucrose. And also sucrose plus acid. Okay, so the one that changed into dark here because I'm using 1 gram per liter is so concentrated lah. So meaning that it becomes so dark lah. So meaning that we know this one is a glucose. Okay, the one that doesn't change is the sucrose. This maybe the one at the back is probably the sucrose plus acid lah. Okay. This also there are some change. Maybe there are some sucrose change into there are no acid, but then maybe because of heat lah. Okay, so you get like that. Okay, so that's the thing. Okay, so that's one part. You want to differentiate which one is sucrose, which one is glucose lah. Here I cannot see which one is which lah. So that's one part. You differentiate sucrose and glucose. Now, if you use what we call different concentration, what will happen? So if you use a different concentration of glucose, so for example, what I put inside the beaker now is basically the glucose only, but the glucose in a different concentration. So you see, I put this, all of this is glucose, but different concentration. So see what happened. See what happened over time. the color change. The color change. All of this is glucose. So you can see some are darker than others. So from the eyes, looking with the eyes, it's hard to see which one is which. So that's why you need a machine to give you like a card, the what we call numbers, so that the machine will beam the laser or whatever spectra, and then that thing will absorb the light, and then it give you the absorbance lah. So that's why you need to use machine spectrophotometer in order to give a value for this, so that you can plot the standard curve. So you get all this thing, okay, and then after you got, okay, let's see, so after you finish, let's say after 5 minutes, after 5 minute reaction, I take it out from the what we call from, kenapa color? I take it out from the what we call this hot water, because you don't put it for long. 5 minutes is enough. The reaction already happened. And now what I need to do now, I need to add the what we call, so that thing, the one I bring is basically Rochelle salt. Okay, that is Rochelle salt. So now I add to the what we call to the solution to help the color development. Okay, some people they add the Rochelle salt into DNS straight away. Okay, some researcher they add Rochelle salt into DNS itself. Some don't. Some do like this. So there are different recipe lah. But the idea of Rochelle salt is to halt the development of the color lah. So now I add after the ni. So once I put that, okay. So normally after I put that, I put because it's hot. So in order to further retard the color development, I put all this thing inside the ice bath lah. So you just put all this thing in the ice bath lah. You put everything here in the ice bath. Okay. So you just simply you put there lah. Just simply put lah. Okay. Simply put on the ice bath. Okay. To further stop the color development, because the colder the situation, the less the reaction happen. Okay. So you put in the ice bath. Okay, after that, after all that, this is what? Okay, so this after ice bath, so you can see the difference. So this is what? This is basically this is glucose, this is sucrose. This glucose, this is sucrose. So you can see the difference. For sucrose, nothing changed. Nothing changed. So this sucrose plus acid, the number 3 here is sucrose plus acid. You see there are some change. This I don't know what is this. This what is this? I don't see this acid also lah. Meaning that something happened lah. So this is basically the original DNS, the one, the control original DNS. So you can see the sucrose, the number 2 there, the number 2 from the left, and the original is more or less the same. So there are no reaction. The first one is the glucose. You can see how different lah. And when you add acid, that's what happened lah. Okay, I remember. This sucrose plus acid, but I'm not heat it. Meaning that I add just acid. This sucrose plus acid, and then I heat it first, and then I add DNS. Okay, so you can see the purpose of heating. The purpose of heating. Meaning that this reaction happen. Meaning that when you have sucrose, you add acid, some of the sucrose will be broke down, but not everything. Okay. Here is sucrose plus acid also, but now I panaskan. I put on the fire. I mean not fire lah, but make it hot lah. So the heat will be increase the rate of degradation lah, from sucrose broke down lah. So that's why you got this more darker lah. So that's the idea from this lah. So here, okay. So here how I put in the cuvette, because now this is a different concentration different concentration. So the cuvette come in that polystyrene board. There are a lot of ni lah. So you can see that this is cuvette. 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 So you see the cuvette have like a clean side and also the rough side. Okay. So the rough side for you to hold lah. The clean side is for the light to pass through. So just take a few ml from what we call from your the one that already reacted, and you just put in the cuvette like that. So just put 1, just put 2 and 3 and so on. And then after finish like that, you do all that thing. Okay, you done everything. So now you want to put into the spectrophotometer. Spectrophotometer mana celah ni? Okay, this spectrophotometer. So this is spectrophotometer. So when you open the spectrophotometer, okay, I will not discuss lah about how to use spectrophotometer, because this thing, how to use, you need to go to the what we call the machine itself to do it yourself lah. Because if I explain here also, you don't know, is not ni lah. I just give the idea lah. So you see inside the spectrophotometer, there are like slot for the cuvette. So you just take your cuvette and put there lah. Okay, put there and put the cuvette inside. So this I put the blank first lah. Okay, so you can see first I put this thing. Okay, so the one that I show there, that is the way where the light coming out. Okay, the light coming out. So there are one part only here. So I put the first thing. So this, the one that I put just now, is the blank. It's basically the DNS alone, DNS only. The reason why you need to put blank is because you want to see the other thing relative to that blank. Okay, because if you don't put blank, then you don't know which one is the baseline. So you put blank as a baseline lah. So I put this DNS that is no the control only as a blank, so that when other thing, I check other thing, it will compare with this thing, with the blank lah. So that's why I check this thing first. I put this thing first, and then I close this thing. On the what we call on the spectrophotometer, they are button blank. So you click the blank. Okay. So somehow this machine will sort of like put the baseline, the blank as a baseline lah. Okay. So they are like this blank or whatever lah here. So the idea is just, so after all this thing, you put all the stuff lah. Okay, so you can see there, after I done the blank, zero whatever, then I put everything here. So now I put one by one there lah. So we have like 5. So this machine can receive 5, at least up to 6 lah. Some machine only 1 slot only. Remember, the source is here, the light is here, the light is here. So when the machine work, it will move this thing, move this what we call the slot forward and forward lah. When you close, when you press start, this thing will move ke depan. Because here they are like light source is here only, here. Okay, so when you close, when you press start, they will start measure this first, and then the slot will move a little bit forward, and then it will measure the second one and so on. And when you start, okay, so you see what will happen when you press thing, you get this thing. Okay, so you get like that. So you see number 1, number 2, number 3, number 4, number 5, number 6. So maybe it's not clear there, but at least I don't know how to make it bigger using video, but at least you can see the first one is so dark, the second one is 1.8, okay, 0.18, the third one 0.14, the fourth one 0.10, the fifth 0.04, the sixth 0.004. Mean that it become like sort of like you have like the gradual trend, gradual trend. This is decreased trend, because in this case actually this one, the 2.819 is basically this one, the you see, I put that right, put the darker one first. Okay, you see the first one is the blank, so this is the second darker, not darker, I mean that it become pale and pale. Ya ke? Yalah, because if you look here, you see this dark, and then suddenly it become like yellow there, right? So that's how this machine lah. So you get these numbers. So these numbers is what you use to find here, to put here lah. this is what numbers that thing. So you know each one correspond to certain concentration. So now you can extrapolate this thing. Okay, so that's basically how to use what we call spectrophotometer. And I think that's it lah. That's it for today, because today we just talk about how to use spectrophotometer, DNS, glucose, sucrose, and so on. So this is basically all about. I mean, this is all experiment to be all about glucose and sucrose detection by dinitrosalicylic acid colorimetric method. Okay, any question? Any question? No question? Okay, if no question, then it's okay. We end our class with session of tasbih kafarah and suratul as.